Three. What is a chemical equation? Chemical equation describes a chemical change. The parts of an equation that we have identified. On the left side of the arrow we have the reactants. On the right side of the arrow we have the product. Between the reactants and the products we have the reaction symbol, and we have a name for that reaction symbol. The yellow arrow is called, just like that triangular yellow sign that you have on the road, that the yield to oncoming traffic, right? Remember, the arrow is the yield sign. The yield sign. Also in this location we have activation energy. Every reaction requires some type of energy, whether it's a flame or a spark, an enzyme, something that provides a little bit of heat to get the reaction going. We call that activation energy. And with the reactant is the chemicals that you start with before the reaction. They are written on the left side of the equation. Whereas the product, these are the new chemicals that are formed by the reaction. They're on the right side of the equation. Subscripts and coefficients. Subscripts show how many atoms of an element are in a molecule. They show how many atoms of an element are in a molecule. An example, in H2O we have the 2 showing 2 atoms of hydrogen. The 1 is understood right here. There's only 1 atom of oxygen in a water molecule. So 2 atoms of hydrogen, 1 atom of oxygen. A coefficient. A coefficient shows how many molecules there are of a particular chemical. Using water molecule again, here it shows there are 3 molecules of water. 3 molecules of water. As it fill in. So this means that there are 3 molecules of water, as I just said. If we watch the diagram, we can see 4 hydrogen atoms combining with 2 oxygen atoms, and then leaving as 2 molecules of water. So here come the 4 atoms of hydrogen, 2 atoms of oxygen, leaving as 2 molecules of water. That's your reaction occurring right there. Yesterday you had to write the law of conservation of mass 2 different times, on 2 different pages in your green booklet. Anybody state the law of conservation of mass?
Elements cannot be created or destroyed.
Elements or something
Oh,
else?
I meant molecules.
You're on the right track.
Oh, mass.
Okay? That's why it's law of conservation of mass, right?
Yeah.
Okay, mass cannot be created or destroyed. It can only be what?
Conserve.
Conserved.
Yeah.
Okay? So in a chemical reaction, matter is neither created nor destroyed, only conserved. In other words, the number and the type of atoms going into a reaction must be the same as the number and the type of atoms coming out of a reaction. If you look at an unbalanced equation, on the reactant side here, we see one atom of carbon, and the green ones are 4 atoms of hydrogen. And then we have 2 atoms of oxygen on the red ones. On the product side, we have, again, 1 atom of carbon, 3 atoms of oxygen, and 2 atoms of hydrogen. So the two sides of this equation do not balance. If we add coefficients, this is what the balanced equation looks like. If we add a coefficient here and a coefficient here, meaning that we have 2 molecules of oxygen are needed in the reactant side, and 2 molecules of water are produced on the product side. If we add these coefficients, that's how the reaction looks. So on the reactant side, we have an atom of carbon, and we have 4 atoms of hydrogen and 4 atoms of oxygen. On the product side, we have 1 atom of carbon, we have 4 atoms of hydrogen, and we have 4 atoms of oxygen. So that's what the balanced equation looks like, and this is the molecular model description of the equation. Rules of the game. You're gonna play the game, you have to have rules, right?
Wait, we're doing it now?
No.
The game is balancing the equation,
Oh.
okay? Number 1, matter cannot be created or destroyed. Meaning it has to be the same number of atoms on both sides of the equation when you're done. 2, subscripts cannot be added, removed, or changed. Like in water molecule H2O, you cannot take the 2 away and do anything with it. You can only change coefficients. Coefficients go in front of the molecules. Not in the middle of them, not behind them. Coefficients can only go in front of the chemical formulas, never in the middle of the formulas. A few extra tips. Try balancing the big formulas first, save the free elements for last. If the same polyatomic ion appears on both sides of the equation, it's usually okay to treat it as one unit. So if we have a individual oxygen O2 on the reactant side and an O2 on the product side, it says it's usually okay to treat it as one unit. We put a coefficient in front of it. There's no one particular way to balance equations. Some equations are harder to balance than others and might require some creative activity to solve it. Balancing equations. In the back of your booklet, you have an area where there's a sheet of scratch paper, a white sheet of paper. We've used it before. You can also use the inside of the back cover. You just need to write down N2 plus H2, and then the yield zero, and the product, which is NH3. Now, if we look at the number of reactants and products on each side, we see that currently there are only 2 nitrogen atoms on the reactant side, and there are 2 hydrogen atoms on the reactant side. On the product side, we currently have 1 nitrogen, and we have 3 hydrogens. Is it balanced?
No.
No. We have more hydrogen on one side than the other, and we have more nitrogen on more on one side than the other. So I want you to take just a minute and a half, 2 minutes here, and see if you can put coefficients in there to determine how the balancing is going to work out. Oh, are you gonna do this? Asher, you gonna do this?
Yes.
Kinda hard to when you're turning around talking.
Like in what way? Yeah, shit. Yeah, I have his break. If you get dreads, you'll look so much cuter. If you get dreads, you would look so much cuter. You would look so much cuter. I mean, he already is, but he'll look cuter. Okay, what do you do? Yes, sir. Yes, you pronounce it right. People usually pronounce it as mobile. People usually pronounce my last name as mobile. Yeah. Lana? Mobile. Well, she's so obsessed with that. Seisha. What's my last name?
Mobile.
Your last name is nobody.
Not like that. Not like that. It's not pronounced like how you say.
I don't know what's your last name. I don't know what your name is.
Well, my last name isn't called Moore.
Are you serious?
Word.
Okay? If we put a 2 in front of the nitrogen on the product side, that gives us 2 nitrogen and 6 hydrogen.
Oh, yeah.
So we have 2 nitrogen on both sides, and we have 6 hydrogen on the product side and only 2 on the reactant side. So over on the reactant side, we have to add a 3, which gives us 6 hydrogen on the reactant side, 6 hydrogen on the product side, and 2 nitrogen on both sides. So it's balanced. If we look at the molecular models, we have 2 nitrogen, and we have 1, 2, 3, 4, 5, 6 hydrogen. And then on the product side, we have 2 nitrogen, the 2 blue ones. And then we have 1, 2, 3, 4, 5, 6 hydrogen on the product side. They are different substances, that could have different chemical properties, but we still have the same number of atoms on both sides. Weston? There's somebody there right now, we have one person waiting.
Why is it right there? Chuck Weston.
Okay, we have a second equation. We have potassium, chlorine, and oxygen. Potassium chloride on the left-hand side, on the reactant side. And we have potassium and chlorine and oxygen on the right-hand side. But we have one potassium on each side, we have one chlorine on each side, but we have 3 oxygen on one side and 2 oxygen on the other side. So we need to figure out what we are going to do with our coefficients so that we can balance the equation. So put the equation in the back of your booklet and use your pencil to add and erase if you need to until you get even reactants and products on both sides.
Cool. What's this? What's this?
How am I supposed to figure that out?
May I go to the bathroom when Carly comes back? Okay.
Anybody have this one balanced yet?
No.
Are you going? I can't. Wait, no. It's gotta be
Okay.
Are we supposed to be doing this in the back of our book?
You have to put coefficients, you have to put numbers in
Oh, wow.
here, so that you put a 2 right there, and you have to have 2 of these, 2 of these, and 6 of these. So that's 2 times 3. If you put a 2 right here, you would have 2 of these, 2 of those. Put 3 in front of this one, because plus is there, you put 3 in front of this one, you give me 6. Okay? If we put a 2 in front of the products, or the reactants, this 2 gives us 2 potassium, it gives us 2 chlorine, and it gives us how many oxygen? 6. And then over here, this 3 gives us how many oxygen? 6. So our oxygens are good on both sides, right? But over here on this side, we still only have 1 potassium and 1 chlorine, so what do we need right here? A 2, right?
Yeah.
Okay. So we'll take care of what we did first. And now when we put a 2 there, that allows the potassium and the chlorine to become 2s. So now both sides of our equation are balanced. We have 2 potassium on both sides, we have 2 chlorine on both sides, and we have 2 oxygen. There's 6 oxygen on both sides. Okay? So we see how important the coefficients are, and the All trips have to remain the same. If you look at the molecular model of both sides, we have 3, 6 oxygen right here. We have 2 hydrogen, or 2 potassium, excuse me, and 2 chlorine.
They came back before.
Over here we have 2 potassium, 2 chlorine, and
I know.
6
They're
oxygen.
more Greeks, except for him.
I'd like you to boot up your PLD to the gizmo.
No, thank you. Can I just go to the bathroom?
Charlie's not back yet.
I don't think she's gonna
What's
come
that?
back for a while.
She didn't go, she signed up for
She
that.
probably didn't go.
She signed out, but she might.
How long has she been gone?
She takes a pretty long time, but she's
I mean, if you know Carla, she's talking to me.
Been to the chemical change run, yep.
One minute, I want to finish it. I ordered the fucking best box.
So looking on page 58, it says a student mixes baking soda and vinegar in a glass. What is the evidence that a chemical reaction has occurred? Well, some of those evidences are listed right down on the top of the table there. It says that evidence of a chemical reaction includes bubbles, which means there's gas production, release of light, release of heat, which means there'd be a temperature change, a color change, loud sounds, and or precipitate forms. Okay? So they want us to put down, actually, we did this over on page 53 at the, when we did the reaction last week Friday. So if we go to page 53, it gives us a lot of the things that we should have seen in demonstration number 2 for a chemical change. Again, just like we read on the other one, bubbles, odor change, color change. There wasn't any release of light, there wasn't any release of heat. We didn't hear any sounds, and there wasn't a precipitate that formed. The water would have to evaporate in order for that to happen. So what you had on page 53 for that demo number 2, you simply need to write in on the top of page 58. Then number 2 says chemical reactions follow the law of conservation of mass. What is the law of conservation of mass? We identified that at the beginning of class, right?
Mm-hmm.
What is it, Jocelyn?
It's where,
Mass Mass.
I forgot what the exact wording was, but it
Mass cannot be created or,
Destroyed.
okay, it can only be, conserved.
Yes.
Mass cannot be created or destroyed,
Well,
it can only be conserved. Okay? Then it says a chemical change or a chemical reaction occurs when one or more substances called reactants are transformed into different substances or products. In the chemical changes gizmo, you will look for evidence of chemical reactions. Fill out the data table below with the observations of the chemical reactions and evidence. We have read through those pieces of evidence. You can go back to them again on your own. But in bold print it says, make sure to put the thermometer in each experiment. It doesn't really say put, it says put, but change the B to a B, or put. Okay, then across the top of your table it says, it gives the different experiments that you're supposed to come up with the drop-down menus. It says properties of substances before the experiment, and then the next one says properties of substances before the experiment again. So you need to change that one to properties of substances after the experiment. It's the third column over, the top of the table. You're supposed to put the properties of the substances after the experiment. Okay, then you're supposed to put in some observations, and then list some evidence for a chemical reaction. So let's look at the first one. The one that they give us a sample of, and we'll see if their information is correct. Sodium and water. We have a normal setup. We want to label the reactants, so here we're labeling sodium and water. We want to show the chemical equation, and we want to show the balanced equation. If you remember from our directions, it says make sure to put the thermometer in each experiment. So let's take the thermometer, we'll put it up here. Okay. Sodium is over here in this container. The weight is 403 grams. So we want to look at it after the experiment and see if that mass has changed. So make sure you mark 403 because it's done that when we started at. The thermometer is going to start at 21 degrees Celsius, room temperature. So we go over here and we hit the control and it runs the experiment. Okay, we saw some fizzing that occurred, right? We saw gas escape out the top of the flask. The water was blue and now it is clear, right? Cleared up. The temperature went up. Temperature went from 21 degrees Celsius to 59 degrees Celsius. Does this sound like the information that they have recorded for us? Does it look correct?
Yeah.
Okay. So when we do the others, we need to collect this type of information. This is showing us what it is they want us to do. Okay, so let's go to the next one where we have sodium and chlorine. So sodium is already up here. All I have to do is go to the drop-down menu and change it to chlorine. Normal setup. Label the reactants. They're labeled. And we show the chemical equation and we show the balanced equation. I am going to take the thermometer and put it in the flask. Okay. It looks to me like there is a yellow glow or gas in there from the chlorine. It says chlorine gas, right? The gas is kind of hovering in the bottom of the flask. And we're supposed to make an observation before the experiment, right? So I need to write what you see before the experiment. Temperature again is at 21 degrees, room temperature, 21 degrees Celsius. The mass is 363 grams. Note the color of the sodium. What color is the sodium? Silver? Okay.
Like, yeah.
So you want to record before you start the experiment that the sodium is silver. And The water is gonna be used as a catalyst. A catalyst is used to help get a chemical reaction started. Okay? So let's see what happens. Okay? Saw a flame, saw a flash of light, all of the liquid burned off.
How do you get
It
that?
left a precipitate, which is kind of a gold color, right, on the bottom. And then this white piece is the sodium. The sodium changed from silver to white. And then the top of the flask has a crust on it from the gas that escaped. Some of it settled on the inside of the flask. You can see that it's kind of dark black. It's like a soot. The mass went from, what was it, 303 to 366.1. Temperature went from 21 degrees Celsius to 100 degrees Celsius. So there's a lot of stuff. Did we see a flash of light? When you put the sodium in there, there was a flash of light, right? So we need to record that too. And all the liquid disappeared that was in there during that, after the reaction. It was there before the reaction, but not after the reaction. Okay? We can actually run it one more time in case we missed something. Have to make sure to put the thermometer back in there. Besides the flash, wasn't there a flame too? You wanna make sure you put that flame down as evidence. You can redo this on your own computer. Keep blocking the site. She not an RU for me? Yeah. That's a restriction. He has a restriction. Probably why he won't work that. We're up here. Okay, so that is the second experiment, sodium and chlorine. Need to go back for more information, you can. If we're gonna do the third experiment, we have to go up here and drop down menu, go to hydrogen peroxide. And then the potassium iodide and dish soap. And I'm gonna show the equations again. Grab the thermometer. Put it in there. So what does the potassium iodide look like ahead of time? It's a yellow liquid, right?
Mm-hmm.
The soap is green. The hydrogen peroxide is,
Explosion.
looks kind of blue, doesn't it? The mass is 426.6. The temperature is room temperature, 21 degrees Celsius. Okay.
Ooh.
Elephant toothpaste.
Okay. The liquid that was in the flask changed color. You can still see part of it right here. And then a foam came out that was light green. So this is what it looks like after the experiment.
Is it, elephant toothpaste?
It would be the same material. If you want to go back, if you think you might have missed something, you can go back and do it again. That's the nice thing about this, is that we can redo it quickly. See any color changes that we might have missed. The liquid that was in the flask changed to a dark green. The foam that came out was a lighter green. The mass afterwards is 426.5 grams. Temperature went from 21 degrees Celsius to 71 degrees Celsius. Okay. There are three other, once you finish recording all of your observations and evidence for those three on page 58, there are three other ones on page 59. Three other reactions for you to observe and record information on. You have time right now to move forward with those other three, unless you need to go back to the ones that you just did. You can move at your own pace from here. Need a little time tomorrow to finish these.
Okay.
Do that.
Yeah. Until death. That's like one reason why I'm not working. I'm too tired. But I do wish you and Caitlin out. Okay?
But you didn't like Supernatural.
Bro, we went over this like a million times. Yes. But I do wish you and Caitlin out. Caitlin's in band. Yeah, and she's in Oregon. To be exact. He's a trombone. Hi, Casey. Oh, that's a good picture. I gotta use my nose. Ew. Nothing happened to the rock. What's the lotion?